Hey everyone, this is part 2 of decision tree videos. In last video, we learned about trees, entropy, information gain, and actually built the cat classifier. But in today's video, we are going to learn something advanced, like one-hot encoding, continuous feature, regression using decision trees, and finally code it ourselves like our every other video. So without wasting any further time, let's start with one-hot encoding. In previous videos, we saw examples like ear shape, face shape, etc. with just two possible values like pointy or non-pointy and round or non-round face. It was good for understanding the concepts, but in real life that would not be the case. You would typically have more than two possible values for each feature. Like for ears, they could be pointy, floppy, or round, or for face, it could be round, rectangular, or oval. So in that case, we use one-hot encoding technique. One-hot encoding is a technique used to convert categorical data into a numerical format that machine learning algorithms can understand. Imagine you have three ear shapes, pointy, floppy, or round. If we give them numbers like pointy equal to 0, floppy equal to 1, and round equal to 2, the decision tree will think these numbers have an order. It will believe pointy is smaller than floppy and floppy is smaller than round. But in reality, ear shapes don't have order. They are just different types, not better or worse. Because the tree thinks that's an order, it could only split the categories in certain ways. It can ask, is the number less than 0.5, which separates pointy from rest, or is the number less than 1.5, which separates pointy and floppy together from round. But what if the true pattern in your data is that floppy ears are special and other are similar? With number encoding, the tree can never directly ask, is it floppy ears? Because floppy sits in the middle and gets grouped with either pointy or round, depending on the split. One-hot encoding solves this by creating separate columns, new feature for each ear. Instead of column with number 1, 2, 3, we create three columns, one for pointy, one for floppy, and one for round. Each column contains either 0, which is no, or 1, which is yes. Now the tree can ask simple yes-no questions like is it floppy ear, or is it pointy ears, or even is it either pointy or round? By checking both columns, this gives the tree complete freedom to find the best way to split the data without being forced to an unnatural order. And then we train model just like we did in our last video, but treating each ear type as individual feature. So now we have seen what to do if feature has two or more categorical values. But what if feature is a number? Like what to do if we want to use weight to classify an animal as cat or dog? Weight is a continuous feature. It can be any value like 7.2 kgs, 8.8 kgs, or even 15 kg. With categorical values, we split by asking, does it belong to this category? But with continuous feature, we can't do this because there are too many possible values. Instead, we pick a threshold, a number, and split the data into two groups, those with weight less than or equal to the threshold or with the weight greater than the threshold. For example, we set threshold equal to 8 kgs. So, left branch gets all the lighter animals and right branch gets all the heavier ones. But you may ask, how do we choose the best threshold? So we try several candidates, which are usually the midpoints between consecutive distinct weight values in our dataset. For each candidate, we calculate the information gain. The threshold that gives the largest information gain wins, and the tree uses the split for that feature. In example, the dataset has 10 animals, half are cats and half are non-cats. So the starting entropy is 1. We test three thresholds, 8, 9 and 10 pounds. The split is at 9 pounds. It gives the highest information gains, 0.61, because it separates the data into pure left group and a right group that is mostly non-cats. That also tells us that if we split the weight at 9 pounds, we get a much cleaner separation than hitting at 8 or 10 pounds. So to handle continuous feature in a decision tree, we simply turn them into a binary question using a threshold, and we let the algorithm find the threshold that best separates this class. This way, continuous feature fit right into the tree building process. And coming to the final concept of this video, regression using decision trees. By far, we have seen how to handle features with multiple values and even continuous feature like weight. Now let's see how to use the same feature to predict a number, like actual weight of an animal. So let's tweak a dataset from earlier a bit. Instead of asking is it a cat or not, we now want to predict how many pounds a cat weighs based on its ear shape, face shape, and whiskers. Just like before, we will build a tree by asking yes or no question from the features. But now, at the bottom of the tree, the leaves, we won't output cat or not cat. Instead, we will output a number, the average weight of all training animals that ended up in that leaf. To decide which question to put at top, we need to find a way to measure how spread out the weights are. In classification, we use entropy. For regression, we use variance. A good split is one that makes the weight inside each child group as similar as possible, meaning low variance. So we look at every possible split, ear shape, face shape, whiskers, and pick the one that reduces the variance the most. Let's see how that works. If we split on ear shape, we put 5 pointy-eared cats in one group and 5 pointy-eared cats in another. Pointy group weights 7.2, 9.2, 8.4, 7.6, 10.2. These are relatively close, so their variance is low, about 1.37. Floppy group weights 8.8, 15, 11, 18, 20. These are much more spread out, so their variance is high, about 21.87. We combine the two variances, weighted how many animals are in each group to get a combined variance of about 11.62. Compare that to a variance of all 10 weights together, about 20.51. The split reduced the variance by 8.89, a big drop. Other splits like splitting on face shape or whiskers don't reduce the variance as much, so the tree decides to start with ear shape question. Now we continue splitting each group separately. For the pointy ear cats, the best next question is face shape round or not. Round face weights are, and their average is 8.35. Not round face, just one cat weighing 9.2, so average is 9.2. For the floppy ear cats, we again split on face shape. For round, average is 17.7 and not for round is 9.9. Once we can't improve the variance anymore, or we hit a stopping rule like a minimum number of cats per leaf, we stop. Now each leaf holds a small, pure enough group and we store the average weight of that group. And that's the beauty of regression with decision trees. We build a tree exactly like before, but instead of counting votes for a class, we average numbers in the leaves. It's simple, intuitive way to handle both categorical and continuous feature when the thing we want to predict is a number.